Chapter 4.1, Graphing Solutions of Quadratic Equations. Let's talk about the difference between a quadratic function and a quadratic equation. Quadratic functions can be equal to many different values. So f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. Notice that we have two variables. So depending what we put in for x, we get different values out for y or for f of x. So depending what we input for the x value, we get different values out for y or f of x. For a quadratic equation, we have a specific number that the equation is equal to. So this value does not change. We now only have one variable, which is inside the equation, which is x in this case. So quadratic functions, we have two variables. Quadratic equations, we only have one variable. To solve a quadratic equation, find the values of x that make the quadratic function equal to 0. F of x equals 0 or y equals 0. That is, find the x-intercepts of the quadratic function, also known as the roots, zeros, or solutions. We can find x-intercepts graphically using graphing calculator or algebraically using factoring, completing the square, or the quadratic formula. In this lesson, we are just focusing on solving graphically. First step, move all terms to one side so the quadratic equation is equal to 0. Second step, using your graphing calculator, graph the quadratic function and determine the x-intercepts, also known as the zeros, roots, solutions. Example, find the solutions of 0 equals x squared plus x minus 6. Bring up our graphing calculator. Go to y equals, clear whatever you have there, and enter the function x squared plus x minus 6. Graph that. If you need to change your window to standard on a TI, you can do zoom and then choose the option that is standard, which is 3 for me. If you're using a Casio, choose window and then F3 for standard. And we get this. We want to find our solutions or our roots, our zeros, our x-intercepts. All of those mean the same thing. TI's second trace, number 2, they're called zeros in the TI. We have to go left bound, so if I'm doing the left x-intercept, I have to be above in this case. Hit enter. Right bound would be below. Hit enter. Hit enter again if you need to, and it says x is -3. Then do the second one, second trace, number 2 again. Left of this x-intercept would be below. Hit enter. Right of that x-intercept would be above. Hit enter again if you need to, and we get x equals 2. So x equals -3. And x equals 2. Those are the solutions for this quadratic equation. What did we do to get that? We graphed y equals x squared plus x minus 6. Then we find the y-intercepts, also called zeros, roots, or solutions. And then let's draw a picture of our graph. So we have a x-intercept at -3 and an x-intercept at 2. Let's find the vertex of the parabola. Second trace. This is a minimum, so number 3 here, or Cassio's F5, and then whichever one is minimum. Left bound of the minimum for TIs would be there. Enter. Right bound would be here. Enter. Enter again if you need to. -0.5 and -6.25. So about there. And another point we can plot. Our y-intercept is -6, since this is in general form. The c value in general form is your y-intercept. So we have a y-intercept at -6, which means we also have a point at -1, -6, since the parabola is symmetrical about the vertex. Join those points together. And there is the graph of y equals x squared plus x minus 6. Next one, find the roots of -x squared plus 3x equals 2. First, we want to move everything to one side. So you could move everything to the left side by subtracting 2. And then you would get -x squared plus 3x minus 2 equals 0. Or you could move everything to the right side by adding x squared and subtracting 3x. Then we would get 0 equals x squared minus 3x plus 2. Either way, you'll get the same x-intercept, so you'll get the same solutions. Let's go back to y equals, clear our last equation, enter this function y equals either -x squared plus 3x minus 2, which gives us this graph, or you can enter the positive one. I'll do that one after. So let's find the x-intercepts here. I'm just going to zoom in a bit to make it easier to see. There we go. So I can see the space between my x-intercepts. I want to find those x-intercepts. Second trace, number 2. Left bound of the first one would be here. Enter. Right bound would be above, but make sure I'm between my two x-intercepts. So if I look there, I am between my two x-intercepts. Hit enter. Hit enter again if you need to, but it is at 1. Looks like the other one's at 2. Let's check it out. Second trace, number 2. Left of that x-intercept would be up above. Hit enter. Right of that x-intercept would be below. Hit enter. Hit enter again if you need to. And this x-intercept is at 2. Let's find our vertex. Second trace, number 4. This is a maximum. Left of the vertex, enter. Right of the vertex, enter. Enter again if you need. And it is at 1.5 and 0.25, so about there. And then from the equation, we can see that our y-intercept is -2. In general form, the c value is -2. So we have a point there on the y-axis, and then because it's symmetrical and our vertex is 1.5 units to the right of that point, then another 1.5 units to the right, we would have a point right there at x equals 3 and y is -2. And we can join those points together to get our parabola. And that is the graph of y equals -x squared plus 3x minus 2. If you're using a Casio to find your x-intercepts, you should have just done F5 and then they're called the roots. And then to find the maximum, do F5 and then choose the max option. And if you graph the positive one, we can do that as well. So go back to y equals. I'm going to keep this one here, and I'm going to enter the positive as y2. So x squared minus 3x plus 2. Graph that, and it's just the reflection of the one we've already drawn across the x-axis. So we would have a positive 2 y-intercept, a positive 2 y value when x is 3. Our x-intercepts stay the same. Our vertex would become a minimum at negative 0.25, and then we can join our points together to draw our parabola. And that is the graph of y equals 2x minus 3x plus 2. Hi, this is Editing Corey here. I realized that I wrote y equals 2x when I meant to write y equals x squared. So this here should say y equals x squared minus 3x plus 2. Our solutions were x equals 1 and x equals 2. Example, the length of a rectangle is 5 centimeters greater than twice the width. The area is 33 centimeters squared. Find the dimensions of the rectangle. First thing I would suggest is to draw a picture of the shape. So we have a rectangle. We know the area of the rectangle. It says the area is 33 centimeters squared, so A equals 33 centimeters squared. The length of a rectangle is 5 centimeters greater than twice the width. So width, and then the length equals 5 centimeters greater. That would be plus 5. Twice the width would be 2w. 2 times w is twice the width. So length is 5 plus 2w, 5 centimeters more than twice the width, or 2w plus 5. Either way is fine. And then it says find the dimensions of the rectangle. So we need an equation. We have area equals length times width. Area is 33, so 33 equals length times width. But I can't solve this if I have two variables. I need to have one variable to solve. But I can rewrite length in terms of w because it equals 5 plus 2w. Then I can write 33 equals 5 plus 2w in brackets times w. And then I can solve. So let's multiply this w into the brackets. We get 33 equals 5w plus 2w squared. Let's move everything to one side by subtracting 33. And we get 0 equals 5w plus 2w squared minus 33. And then I'm going to put this in general form, so the w squared term first. 0 equals 2w squared plus 5w minus 33. Now we have a quadratic equation, so we can solve that graphically. Go back to y equals, clear the two equations that you had, and enter 2x squared plus 5x minus 33. graph that, and here's what we get. I don't see the vertex, but I don't need the vertex. My solutions are the x-intercepts. So second trace if you're on a TI. Number 2, left bound of the left one would be up, enter. Right bound would be below, enter, enter again if you need to. And we get x equals negative 5.5. Second one, second trace, number 2, left of that x-intercept would be below, enter. Right of that x-intercept would be above, enter, enter again if you need to. We get x equals 3. Now, x in our situation, what variable did we have in the equation? It was w. So x represents w, which is the width of the rectangle. Do both of these numbers make sense? X equals negative 5.5 and x equals 3. If those are widths, it doesn't make sense to have a negative width. How can you have a negative width? So this is not a possible solution because width can't be negative. Then we would have that width equals 3, and this was in centimeters. So our width is 3 centimeters. We want the dimensions of the rectangle, so that means we want both the width and the length. Now we can solve for length. We know that length equals 5 plus 2w. So length equals 5 plus 2w. Length equals 5 plus 2 times 3. Length equals 5 plus 2 times 3 is 6. So length equals 11 centimeters. The width is 3 centimeters. The length is 11 centimeters. Number of x-intercepts. How many x-intercepts can a quadratic function have? Well, we've seen above that we can have 2 x-intercepts, which could look like this if the parabola is opening up. Or we could have a parabola opening down with 2 x-intercepts. We could also have 1 x-intercept, which will be the vertex. So if the parabola opens down and has 1 x-intercept, it'll look something like this. And if it opens up and has 1 x-intercept, it'll look something like this. So it meets the x-axis at the vertex and then bounces back off. We can also have 0 solutions or 0 x-intercepts. If the parabola opens up, it could look something like this. And if it opens down, it could look like this. So we see that the parabola does not ever touch or cross the x-axis, therefore there are 0 x-intercepts. That brings us to the end of Chapter 4, Lesson 1.